This video is for 5.3, page 318, 13 through 31 the odds, and 41 through 43 extra credit. 13 and 15 both look at this triangle here. And all three of these lines are medians. They go from midpoints to the opposite vertices. There's a special relationship between the medians and where they meet, here in the middle. This point in the middle is called the centroid. For 13 and 15, we use this triangle right here. And these three lines are called medians. They go from midpoints, A, B, and C, to the opposite vertices, J, G, and H. Where those three medians meet is called the centroid. And there's a special relationship between the medians and the centroids. Each median, 2/3 of it is on one side of the centroid and 1/3 of it on the other. So 2/3 of your median is here and 1/3 of it is there. 2/3 of this median, 1/3 of this median. This means if they give us certain values like HC being 10.8, we can figure out HP by taking 2/3 of it. Or if they tell us that AP or PA is 2.9, I know that's 1/3 of my entire median. So JP is 2/3, double that. My answers are 7.2 and 5.8. For 17, the orthocenter of a triangle is where all three altitudes meet. So let's plot it and figure out the altitudes separately. So here's the graph of triangle XYZ. And remember, for altitude, you start from each vertex and you have to connect to the opposite side in such a way to form a 90-degree angle. So the slopes are going to be opposite reciprocals of that opposite side, which is helpful when we notice that YZ is a vertical line. This means that our opposite reciprocal is going to be a horizontal line. I could go ahead and draw in the altitude here from vertex X that connects to YZ and is perpendicular. If you didn't really recognize that right away, you could just use the change in slope formula to figure out the same exact thing. If I figured out my initial slope was undefined and I flipped and took the opposite reciprocal, it's going to be 0. And I know that it has to pass through that initial point, and my equation of this line would become y is equal to -2. I take 0 and plug that in. I take my coordinates for x, and I plug those in, -2 and -2. And 0 times anything is going to be 0, and then I just simplify from here, and my line is y is equal to -2, which is this horizontal line here. So to figure out the next altitude, I'm going to take the slope of one of the original side lengths, xy. If I use my change in slope formula, 12/8 is my slope. If I want to reduce that or simplify that, this could become 3/2. If I take the opposite reciprocal, I'm going to have -2/3 as my slope. And I'm looking at xy here. What vertex is across from that? It's z. So I'm considering the point 6, -6. From this, I can build a formula. Y minus the -6 is equal to -2/3 times the quantity x minus 6. So this is helpful to figure out the slope of the altitude, or the whole equation of the line of the altitude. But since I know my slope was -2/3, I could have just started from z and went to here, that's over 3 up 2, to here, that's over 3 up 2, to here, that's over 3 up 2, and this is going to be my altitude. And I can see a point where these two meet. That's actually going to be the answer, 0, -2. So you could solve it graphically by figuring out where the lines intersect. But just in case you did xz instead, we'll go ahead and find the third equation of a line here. Using the slope formula, you get -1/2. So if I take the opposite reciprocal, my new slope is going to be 2. And I know that if I'm looking at xz, the opposite vertex is y. So I'm going to use the point 6/10. I'm going to build my line. Y minus 10 is equal to 2 times x minus 6. If I simplify this, I end up with 2x minus 12 plus 10. So minus 2 is equal to y. And a similar trick to before, since my slope is 2, I could have started from y and went down 2 left 1, down 2 left 1, down 2 left 1, and done that a few times to figure out where I'm going to connect. And again, that line crosses the other two, and they all meet at this orthocenter, which is at 0, -2. graphically. The other way to find this orthocenter, other than graphing it, is to do it algebraically. So these were the equations for my three different altitudes. To find where they intersect, I can create a system. So I can pick any two I want. I might pick the ones without fractions. And I can solve these like a system. It makes sense to me to use substitution. If I do so, I end up with negative 2 is equal to 2x minus 2. If I add 2 to both sides, I get 0 is equal to 2x, so x is equal to 0. And if I plug that back into my original equation, I get y is equal to 2 times 0 minus 2, or y is equal to negative 2. 0, negative 2. So here is my triangle RST, and this one's going to be pretty easy because I have a horizontal and a vertical line. So to figure out the opposite reciprocal of those, it's going to be the opposite, whether it's horizontal to vertical or horizontal. And I know it has to pass through the opposite vertex. So RS, which is horizontal, the altitude is going to be vertical. And I know it has to pass through T, so my altitude is going to be this line right here. Similarly, ST is vertical, so the altitude is going to be horizontal and has to pass through R. So the altitude is going to be right here. And these two lines, I can already see where they cross. That's at negative 2, 9, which is my answer. There is, of course, a much longer path to that solution, but that's the simple way. For 21, looking at GL, I know that GP is 8, so I'm going to multiply it by 3 halves, since GP is 2/3 of the total, and I get 12. For 23, HL is going to be equal to LJ, so it's going to be 5. 25, the perimeter of the entire triangle. I can figure out the 6.5 and the 5 from those midpoints. They're equivalent. To figure out GJ, though, I'm going to have to use the Pythagorean Theorem. I can recognize the right triangle is here, a linear pair with the other right triangle. And I know that 5 squared plus 12 squared is equal to c squared, which tells me GJ is equal to 13. So I have 13 plus the 13 from the opposite side plus the 10, and that gives me 36 units. So for 27, one strategy is to find the midpoints of each of these three and connect them to the opposite vertices and identify where the lines meet. So if I find my three midpoints by taking the midpoint formula, adding together the x's, taking the average, adding together the y's, taking the average, and I plot them like so. If I go ahead and draw those medians from those midpoints to the opposite vertices, you can see that these meet at 10, negative 2. And that's my centroid. So 29, I just take 27, which is 1/3 of this, and I double it to figure out PZ. They tell us that PZ is equal to 2n plus 17 also. So I can set this equal to 54 and solve for n. If I do so, n is equal to 18.5. If I plug that into QZ, I end up with 48. 4 times 18.5 minus 26.